Alrighty, so in this video we're continuing to talk about absolute value. So in the last video was an introduction to absolute value. So if you haven't watched that or done those assignments, go back and watch that one just so you understand the basic idea here. We're going to review it just a little bit here anyway. But so using a number line, we have been practicing the idea that distance can move to the right, which would be positive if we move right on a number line, or left, which would be negative if you move left on a number line. And on the introduction, the midpoint was always 0. That was our middle. Well, now the midpoint's going to be somewhere else. It's not always going to be 0. That's not practical. That's just kind of a introduction to absolute value. But now we're going to have, we're going to be moving right and left the same distance from a certain point, which we can call the midpoint. So we name these case 1, which case 1 is to the right, and case 2. So instead of just saying right and left, we can say case 1 and case 2. So there's always two cases when we're talking about absolute value because it's distance, and a number line goes both right and left. So we have to go both ways. So now we can use the algebraic method to show these two movements. So we're not going to look at a number line on these ones. We're just going to look at the algebra that goes with it. So we have solve for v. We have the absolute value of the sum of 4v plus 2 is 10. So the distance away is going to be 10 from 4v plus 2, both directions. So case 1, remember this is the distance from the midpoint to the right, or positive. So we're going to have 4v plus 2 equals positive 10. I went to the right, so it's positive. Case number 2, remember this is the distance to from the midpoint to the left, or negative. And it always goes in this order. You do positive first and then negative. If this starts as a negative, you stop. It cannot start as a negative. It has to start, really it's not even a negative or positive here. What it is, it's nothing. I'm saying is a distance of 10. Distance is not negative. So once we come down here, now we're giving it positive and negative because we're referencing going to the right, which is positive, or to the left, which is negative. But if I start, if this said equals negative 10, I would immediately stop and click no solution. Okay, so just be careful about that part. You always start with a positive and then go to the negative. All right, so now what we're going to do is we're going to solve this like we would any other equation. I want to get v by itself. So I'm going to subtract 2 from both sides because I always start with addition subtraction. So then 4v would come down. 2 minus 2 cancels, equals 8, because we have 10 minus 2, and that gives us 8. Now I'm going to undo the multiplication here because this is 4 times v, so I'm going to divide by 4 on both sides. 4 divided by 4 is 1, so I have v equals 8 divided by 4 is 2. So this is my first distance. I would land on 2. Now I'm going to do the same thing for negative. So I'm going to do the same 2 steps. I'm going to subtract 2 from both sides because I still, 4v plus 2, this part stays the same for both of them. So I'm going to subtract that. I'd have 4v equals 2 minus 2 is 0. Negative 10 minus 2, remember this means I have negative 10 and I'm going 2 more negative. So I combine and keep that negative sign. And then just like I did up here, I'm going to divide by 4 to get v by itself. 4 divided by 4 cancels, and I have v equals negative 12 divided by 4 is negative 3, because a negative divided by positive is a negative. 12 divided by 4 is 3. So these are my 2 points. It's 2 and 3. And if I looked at a number line, let's see, 1, 2, 3, 4, 1, 2, 4. All right, so this is 2, and this is 1, 2, 3 here. So if I wanted to see what the midpoint was, it's not going to be 0 anymore because 2 is only 2 away from 0, but negative 3 is 3 away from 0. So really, I have 5 full spots if I counted back. Oh, sorry. 1, 2, 3, 4, 5. So it's actually going to be kind of a midpoint that's right there. It's like half. Negative 0.5 is actually the midpoint, or the distance. So I'm going 2.5 to the right, or 2.5 to the left. All right, so now down below we're going to look at another example of absolute value, and we had to deal with this a little bit in the last video. We always want the absolute value to be by itself on the same side, or the one side of the equal sign. So it's got a little bit erased, but it's v minus 4, so the difference of v and 4, the absolute value of the difference of v and 4, plus 14 equals 25. Well, I don't want it to say plus 14. I want just the absolute value to be on this side. So what I'm going to do is I'm going to move that 14 over to the right side of the equal sign here. 14 minus 4 is going to cancel out, and I'm going to have the absolute value of v minus 4 equals, and it's going to be 11 because I just do 25 minus 14, and I have 11 here. So now I can do case 1 and case 2. Remember, this is just another way of referring to going to the right or positive, going to the left or negative. So now I have v minus 4 equals v minus 4 equals. Remember, that part's not going to change. Once I know what the absolute value part of the equation is, and it's by itself, that stays the same in both equations. What changes is I'm going to change this for going right and left. So going to the right is positive, so it just stays 11. Going to the left is negative, so I write negative 11. So now I'm just going to solve this, and all I have is this one step. I'm going to add 4 to both sides because I want to know what just v is. So v, negative 4 plus 4 cancels out. 11 plus 4 is 15. And now we're going to do the same thing on this one. I'm going to add 4 to both sides so that I can get v all by itself. So v, negative 4 plus 4 cancels again. And negative 11 plus 4 is negative 7. So this one, again, I know I've shown, let's see if I can get 11 of them in here. So I'm going to show you algebra tiles again because it's a very good visual way if you're having any kind of trouble with subtracting integers. And remember, you can always do it, kind of switch it around. Instead of saying negative 11 plus 4, because that seems to kind of trip students up a little bit, you can say 11 minus 4, and that's 7, and 11 has more. 11 is bigger than 4 if we're thinking of it that way, and it's negative. So that's why my answer was negative. I have more negatives than positives. So you can think of it that way, but you can also look at it visually. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 9, 10. So 1, 2, 3, 4, 5, 6, 9, 10, 11. And I know those all should be the same size, but, you know, we're just going to pretend like they're all the same size here. And then I have 4 positives, like this. So these are positives. So here's my negative 11 in this situation, and then my positive 4. So I'm visually looking at what does this look like? How can I see this? So when I'm looking at these, they cancel out. I can take one negative for every positive, like this. So I can cross them out, and they no longer are there. They're gone. And I'm just looking at what's left over. So this would be my negative 7 left over. 1, 2, 3, 4, 5, 6, 7. So algebra tiles, great visual way to be able to see the math happening. Sometimes, you know, as we get to much larger numbers, it's going to be a little bit more tedious. So the more we understand this, the less we'll actually have to visualize in this way. But it gives you a very nice way to visualize it in your head as you move forward. All right, so that is solving absolute value equations with case 1 and case 2. So go ahead and go on, Alex, and give it a try.